wrapping up 3.7 on, we can move to absolute value inequalities. Yesterday we learned how to translate and solve absolute value equations. Real quick look at the process. What we learned to do was to rewrite whatever was in the parentheses again, leaving the outside number the same. And then we learned to move over, copy again what was not inside the parentheses, inside the absolute value, is to copy again what was in the absolute value, and then switch the outside number. From there we solved both equations as usual, and everything else did what it was supposed to do. And so that was how we found it. The key thing was anytime you saw the absolute value, you recognized that it was two answers, or potentially two answers, because those of you who got far enough on the homework realized that there are what we call extraneous solutions, which is the one where you actually get the answer but it doesn't work because you cannot have a negative. By the way, just speaking on this right now, if I was to ask you what the absolute value of, what value of x makes 5, we know that 5, the absolute value of 5 is 5. We know the absolute value of negative 5 is 5. And so this would be the answer of x equals 5 and x equals negative 5. Purposely left it on your homework and did not tell you about it because I wanted you to experience it for yourself. But what happens if I say I want the absolute value of something to be negative 5? Well, the problem with that is if I put a 5 in, it's going to turn positive. Even if I put a negative in, it's going to turn positive. This is why it was no solution, because the absolute value equal the actual negative number. Now, it doesn't mean you can't have a negative number, but it means that if the absolute value portion leads to a negative number in the equals portion, then that's not going to work. So that was what it was that was throwing it off. Today we're going to look at absolute value inequalities. What makes an absolute value equality more quote-unquote difficult? The absolute value equations, and it's because of two things. The symbol now indicates a word that we must use whenever we solve. We actually were supposed to use a word on the other ones, but you get away without using it because it really is not that significant whenever you talk about equal signs. The symbol also must switch on the rewrite. So again, there's a few things you need to focus on. Again, those are the two things you really need to focus on more than anything else. First rule of translating absolute value inequality is that the symbol indicates whether we use the compound word and or. The symbols that point to the left, less than and less than or equal to, are going to be for and. Greater than or equal to, require the word or. It looks difficult, but again, I usually try to give you a way to help you remember. Again, your job at that point is to make sure that you actually practice that skill, study that skill, and be ready whenever it counts. And again, even in my 136 class, I have issues with students who chose not to really study that part, and they had major issues on that test, and it cost them a lot of points. So all you have to do is put a little bit of time in, and I promise you it is not hard to tell whether it's and or. But all you have to do is put the words in alphabetical order. Notice A would go first, O would go second. If the symbol points this way, then it's pointing at and. If the symbol points that way, then it's pointing at or. So if the symbol is actually drawn between the words, here's what you'd be looking at. This points at and. This points at or. This points at and. This points at or. And so you can use that to your advantage. Plus there's going to be enough problems where I just have you simply translate it just to make sure you get it. But again, the sign is pointing to the word. Just make sure again you ask for help as soon as you get stuck so I can get you on track soon, so you don't waste 5 to 10 minutes just messing around with a question that's really wasting your time. Again, I will admit it might be a stretch, but you can always try your own way. But just know that you have to know it for the test, actually for the quiz tomorrow. So make sure you're ready for that, because your quiz is actually tomorrow, so you actually only have about a day to get that under control. The second rule is that we must switch the inequality whenever we switch the outside value. We learned that the inequality symbol is very sensitive in terms of whenever we switch the value of x to be negative, that the symbol changes. Same thing here, and whenever we are changing that outside number, it means that this is also going to change. Pretty much, again, the way it works, everything outside of this is going to switch. So you remember, if this was an equal, we would have wrote 3x plus 1 equals 12, 3x plus 1 equals negative 12. Remember that the equal sign did switch, it just didn't look any differently. So we are just going to translate these, not solve these. But again, for those people who kept not solving them and then trying to just translate only, The reason I'm doing this is to save you time on the video so that we don't waste time solving things that don't need to be solved, because I think you already know how to solve this stuff, and if you don't, again, make sure you come back and get assistance. Either way, first thing you would write here is 3x plus 1 greater than or equal to 12. Again, you write it without the bars, same way we did before. But now we must make our decision, is this an and or? And again, what you can do is mentally visualize those two words, mentally put that symbol in between those two words and recognize that it is pointing at the word or. And then again, you copy this side, which is your 3x plus 1. But because that's going to switch, this must switch, and your 12 must become negative. That's all. Alright? Again, 3 dots here, meaning you're supposed to solve. Every time I did my notes in college, this was my way of saying I don't need to do anything else, because I hope you know how to subtract 1 divided by 3, subtract 1 divided by 3. That's a skill you should have already. Here, again, it should start out as 9 minus x less than 14. Again, notice the first thing I do is write it without the bars, just like I did yesterday. That's still the same. But I must now imagine if and is over here and or is over here, and I took this sign, notice that it is pointing at and, so I have to use the word and. Then again, I copy what's inside the bars exactly as is, 9 minus x, switch the sign, switch to 14. Here, we can't do anything yet, because as we learned yesterday, if this was Clark Kent, it's not going to change yet, so we have to kind of shift it first. So we're going to get absolute value of 6x plus 3 less than or equal to 5. Now we can do it because it's alone, so we'll do 6x plus 3 less than or equal to 5. I don't think I need to write the words anymore. That would be pointing at and. Again, hopefully you'll get used to that and is on this side, or is on that side. And then 6x plus 3, switch the symbol, and negative 5. Same thing here. Again, a skill we learned yesterday. I think you did pretty well. Most of my classes don't do as well as you all did on these yesterday. I think we're getting better. Again, but this is not going to change because it's 6, so remember the first thing you want to do is move to 6, end up with absolute value of 5x plus 1 greater than 20. And now we can change it to be 5x plus 1 greater than 20. That is obviously pointing at the word or. 5x plus 1, switch the sign and switch to 20. Again, make sure the only thing you have to really add is that you add the or and that you must switch the sign. Those are the two main key things for you to focus on. I'm going to add one more as soon as we finish this next one. But again, here, what we learned yesterday is that the first number that moves, just like in real algebra, is the weak connection, which is the number that's being added, not the number being multiplied. And then we move the number that's being multiplied. And from there, it's a basic problem. Again, the only difference between this problem and the ones we had in the beginning is that you just have to move some numbers before you actually get to the work that you're here for. So again, you end up with x plus 4 less than or equal to 6. That is obviously pointing at the word and. X plus 4 greater than or equal to negative 6. Just don't forget to switch the sign. Alright. Translating and inequalities. Now this is something that I just added on this year because I think that it will help you out. Your compound inequality, it uses the word and, can be converted to a three-piece inequality because that's really what it's doing anyway. It also will help with your solving because it'll be less confusing. Let's convert some inequalities to be sure. Again, I will do more of my teaching on this as usual when you come up and ask for assistance, because I'm trying to get you the main information so you can come to me and get the actual information that you need. But if you learn well enough on your main information, then there's no need for me killing 20 minutes of your time. But here's what we're looking at. Anytime we have something that has the word and, it is typically the case that you are smaller than a big number and bigger than a small number, which therefore means that you can, and it only works with and, not or, which therefore means that you can take this 2x plus 3 and put it in the middle. You can put your negative 1 over here. Notice that this is pointing at negative 1, so you have it pointing at negative 1. Notice this is pointing at 2x plus 3, and then there you have a compound inequality where you would solve it, subtract 3, divide by 2, and get your answer. There is, again, a question on there that's going to ask you to do this. That is what you'll need to do. So the key thing here is that you have the same exact thing being compared to two numbers, and that it is an AND equation with a smaller number and a bigger number that is bigger than the smaller and smaller than the bigger, or whatever, however you want to say that. I'm sorry, that sounds confusing, but that is what you're looking at whenever you go to put those together. And again, if you come back and you want to know, once you have kind of mastered it, and I don't say mastered it, but once you've got it down pretty well, if you bring me your work, I can actually show you an even shorter shortcut for the AND inequalities with absolute values, because that's what I actually used. I'm just trying to make sure you can at least get them right before you try to get fancy. Again, here's an AND. Notice that it's 5x minus 3. It's smaller than a 12, and it's bigger than a negative 28, which means we can then take our 5x minus 3. This is pointing at negative 28. This is pointing at 5x minus 3. And there's your absolute value inequality, where you would subtract 3, divide by 5, and get your answer. So again, remember, each lesson is mainly focused on two keys. What I did here is extra. Again, it just kind of makes your life easy. But the two keys were, again, you need to determine AND or, which hopefully you have that down for the most part, and then that you need to switch the sign whenever you rewrite it. As long as you take time to review the keys, you should be able to perform well on the assessment tomorrow. Just work hard on the translation part, and the rest is going to fall into place. So go ahead and go into your Math Excel, and again, make sure you ask, because the best lessons you're going to get, especially if you're falling behind, is by coming to talk to me, so I can actually keep you on track and give you other things that will help you to figure things out. Good luck.